Hi, my name is Donovan McMurray, and in this video I'm going to present my research project on concept map effectiveness in computer science education. So this video is broken into 4 parts. First I'll cover what a concept map actually is. Then I'll go into my first experiment, which is my Introduction to Computer Science experiment. Then I have a second experiment that I've called the Traveling Salesman Problem experiment. And finally, I'll cover some concluding remarks. So, to start, what is a concept map? A concept map is a tool used in education, and it represents structured knowledge. Most domains or subjects have structured knowledge, but this particular structured knowledge needs to fit into a hierarchical structure. So in the case of history, while concepts around primary and secondary sources or cyclical patterns within history might fit into a hierarchical structure in this way, a timeline of date event pairs would maybe not fit into this hierarchical structure. That's a linear structure. And for a concept map, toward the top you tend to have general concepts, and toward the bottom will be your specific concepts. The structured knowledge of a concept map is composed of key concepts and the relationships between those concepts. Key concepts are displayed with nodes, and concept relationships are displayed with arrows and the associated relationship text next to the arrow. Now we have a complete picture of a concept map, and what you're looking at is a concept map of concept mapping. So the tool is used in education. So the question remains, are concept maps effective education tools? There's a wide body of research into concept map effectiveness, and a number of subjects such as physics, history, medicine, and language have all shown that concept maps in these subjects are effective. My question, though, is if concept maps are effective for computer science education, and there's not really much research on this specifically. And the reason that I think it's worth researching is because while these other fields have more concrete applications, physics, you can visualize a ball rolling down a hill. Medicine, while it's slightly more abstract and on a level that you're not used to dealing with, maybe the internals of the body and such, it's still rather concrete. Language deals with abstract word types like prepositions, adjectives, adverbs, and the like. But that layer of abstraction of parts of speech are very easily mapped, because if I tell you that you need to learn what an adverb is, and I tell you that quickly is an adverb, then it's very easy to make that connection to a concrete example. Computer science, on the other hand, is very abstract, and often the abstractions are layered. So you need to understand one abstraction to build upon to understand the next. So I don't think we can take it for granted that these findings in other subjects will necessarily transfer to computer science, which is why I devised this experiment. So for my Introduction to Computer Science experiment, I tutor a group of middle schoolers after school in Intro to Programming. And so over the course of 5 weeks, we covered 5 separate lessons. The first week we covered loops, then user input, functions, debugging, and recursion. So the lesson and the work time we did just as we normally would. Then I typically give a review and then a quiz, just so that the students can lock in the topics that we covered that day, and also so I get a sense of how well the students are doing. So for this 5-week experiment, I alternated between the review being in the form of a concept map or just being a bulleted list, which was a non-hierarchical, non-visual review. So these are the 2 separate kind of reviews I used, and I wanted to compare the test results on concept map weeks and non-concept map weeks. So just to make this a little more clear, this is an example review that I gave for our loop class. It's a concept map for loops. It covers some of the more conceptual ideas around loops, the fact that it does repeated computation. It also covers some specific loop types that are available in the programming environment that we use in the classroom. And then at the bottom, it even gives some examples that are specific of types of shapes that you would draw in our graphical-based programming environment that are easier to do with loops than doing manually. The following week, we covered user input, and I covered the same amount of material in this review. The main difference is that the concepts are not linked together as they would be in a concept map, and there's no visual or spatial orientation around them, although I did group similar concepts to similar concepts. So now that the experiment is done, I recorded all of the quiz scores, and these are the averages for each week. So first off, I should say these are out of 100, but I didn't give the students these scores. They really were just an internal metric for me to see how well the students were doing. So don't worry that any student receiving a bad grade had his or her self-esteem damaged. If I were going to return these scores back, I would include some curving and more generous grading. Again, these are just internal scores. So looking at it, it looks like it's possible that concept map weeks the students performed better, but to make sure, I did a little analysis, and the average of the concept map weeks was 64.7 out of 100, and the average test score on a non-concept map week was only 37.2. So I was dealing with a small sample size. We only had 9 students over the course of 5 weeks, and a total of 31 test response over those 5 weeks due to absences and that sort of thing. But using a t-test, this difference in test scores is statistically significant. So I was able to prove my hypothesis that concept maps are more effective than non-concept maps for reviewing in a structured classroom environment. So if we go back to the question, are concept maps effective educational tools? You might be tempted to go ahead and say yes. We can go ahead and conclusively say that they are. But like I mentioned, it might be a little more complicated than that because I was using a small sample size, and while this experiment did lend evidence to the fact that concept maps are effective educational tools for computer science, I did want to gather some more data to see if I could strengthen that claim. So that brings me to my second experiment, which was an online experiment. And since it was online, I couldn't really do the same amount of detailed instruction that I do in the classroom over the course of weeks. So I decided to pick a classic computer science problem that's a little easier to grasp, which is the traveling salesman problem. In this problem, I asked participants to complete an instance of the problem where you have to visit each node once and arrive back at your starting position, and you're also trying to minimize the distance over the entire tour of all of the points. So the setup of this experiment was I had the participants do a round of the traveling salesman problem. Then I provided a review, which again was either a concept map or a bulleted list. And in the review, I provided some strategies, some heuristics for how to find a solution, and some characteristics of optimal solutions. So making this a little more concrete, this is the concept map that I showed the experimental group. As you can see, it has some basic conceptual information about the traveling salesman problem at the top. As you move down, I show the greedy approach and the nearest neighbor approach, which are 2 heuristic-based methods for coming up with an approximate solution, and I show the steps along the bottom of each of those. Then back up closer to the top, I talk about the optimal solution, and I say that the optimal solution will have certain properties, such as that no paths intersect, and if you go around the boundary points in the tour, you should visit them in some sort of order and not out of order. And then for this problem, I show an example optimal solution. So for the control group, I showed a bulleted list of this review, and it's the exact same information. I've just taken away the graphical element and the element of showing how the concepts are related to one another. I measured how much they improved from round 1 to round 2. So a score of 1 means there was no improvement. A score of 2 means they did twice as well on round 2 than they did on round 1. So for the concept map group, they showed an improvement score of 1.19. However, for the control group, there was an improvement score of 1.26. So it actually looks like the control group did better here, but because these numbers were so close and the variance was so wide in the responses that I got, there's no statistical difference between the two. So even though I wasn't able to further prove the hypothesis that concept maps are efficient tools in computer science related education, I did find some interesting information in my online experiment data. So I also asked each participant to tell me how much computer science experience they had. Either they had no computer science experience, they had some, they had much computer science experience, or they were a professional. And this is the distribution I got. Obviously, it's very skewed to the professional side or the high experience side. And this is because while I did put these experiments out on the internet for anyone to take, I asked a lot of my classmates in the online Masters of Computer Science program through Georgia Tech to take my experiment. And so that's obviously not a representative sample of everyone. There's going to be a lot more professional computer scientists, developers, programmers, or at least people who have been exposed to these kinds of things. So when I broke my data down, I did see that the people who were grouped with no computer science experience or even some computer science experience did show better improvement when presented with a concept map. However, based on how my data was distributed and the randomization of it, I just was not able to get enough data of this population of less computer science experience to make any conclusion either. So one avenue of future research would be to target people with less computer science experience who are less likely to already know a bit about the traveling salesman problem and therefore be less able to improve in a quick 7 or 8 minute online survey. The second interesting thing I noticed was at the end of the experiment, I asked each participant to rate how effective they thought the review was. So this has nothing to do with their actual score, but their perception of how well the review helped them. And when I did this, the concept map scored much higher than the bulleted list. And this makes sense because just looking at the two review materials, the bulleted list looks very dense, and while the same amount of information is on the concept map, at least it's a little more easily digestible. So even if I wasn't able to detect a raw effect of the concept map actually improving participant scores, there is something to be said about the fact that they perceived it to be effective because it might bring them back to this educational tool to learn from. So this is also another avenue of potential research to see perceived impact of concept maps over other types of reviews. So, in conclusion, my first experiment, which was the in-person Intro to Computer Science experiment, did show a relationship between concept map reviews and better test scores. So even though my sample size was small, this still lends evidence to the hypothesis, which is already to be expected based on prior research, that concept maps will be an effective tool in computer science education. My second point is that while my online traveling salesman problem experiment didn't have data that proved the hypothesis like I expected it would, it uncovered some interesting trends that are ripe avenues for potential future research. For instance, the fact that the concept map review was perceived to be more effective. Thank you for watching my video, and if you would like to read my full paper, you can see the video description for the link.